Hello, Physics 101. Today I'm going to be explaining the physics behind an internal combustion engine. An internal combustion engine is named as such because the combustion happens internally to the engine. Wow, most of you could have guessed that. Yes, I know, but I just want to be clear. I'm going to be jumping right in. So this is my engine. I'm about to show it to you in a minute. I'm also going to be explaining the physics behind this engine and physics concepts that go inside of this engine and this car, more specifically. So some physics concepts we have, I'm going to be explaining them in a little bit, we have acceleration, we have inertia, we have mechanical energy, we have thermal energy, we have electrical energy, and we also have force. We're not going to be worrying too much about force, but yeah, we have all those, and let's just get right to it. Alright guys, so this is my engine, and I want to be explaining just how an internal combustion engine works before we start how the physics applies to it. So an internal combustion engine works basically by taking in a mixture of fuel and air. So you put in the fuel, as everyone knows, through the gas tank, through the gas cap in the back, and you get air through the vents right here. So air goes through here, through these vents, through these, travels into a duct where or a filter where it cleans the air, and it goes then to the carburetor. And the carburetor also the carburetor is the part of the car which takes in and combines the mixture of air and fuel. And then after that, it finally goes into the cylinders. This is a inline 6 engine because it has 6 cylinders and they are inline. So we call this an inline 6. Most of you guys have a V6, which is the same as this one, but they are in a V formation with 3 on each side. The carburetor, as I was saying, takes in the fuel and air mixture, sends it to the cylinder valves, and then a combustion happens thanks to the spark plugs, which pushes on the valves and the turning rods to then push the connecting turning rod, which is connected to the wheels on the bottom. And basically it transforms thermal energy into mechanical energy by pushing on the valves to the bottom. And I'm going to be showing you that demonstration with something I have right behind me in a minute. But that is how an engine converts thermal energy into mechanical energy. Now I also want to explain, because I have limited time, electrical energy. I'm going to be explaining this really quickly so as to get every topic out, because I have to get 5, as do all of you. So we have electrical energy. Electrical energy is provided through the battery. Most batteries are located in the front of cars, but this one actually does not have it in the front. This one has it in the back, and I would show you, but I don't have the keys on me. It's in the trunk, behind all the you know, the trunk mats and everything. It's under all of that, and so the electrical energy is needed for the spark plugs. Basically, that's all I need. It's needed for the spark plug so it can ignite the fuel and air mixture. These are just the basic components. There's a lot of other components. You know, we have the oil filter, and we have the fan, and we have the cooling system, and all these filters are necessary for an engine, but they're not necessary for the 4-stroke or the internal combustion engine. And these are just what I'm talking about are like the basics of the basics. Okay guys, excellent. So now I want to be showing you this right here is an air pump, and most of you have used one of these in your childhood or whatever. So I'm going to be comparing this to a cylinder or a valve, actually both. So we can imagine this red part as a cylinder, and we can imagine this area as the valve, and this is where the combustion takes place. So the cylinder begins at the top. This is at the beginning of the cycle. And there's 4 steps to this cycle. So first we have intake, which is the intake of fuel and air, and you accomplish that by having your fan turning on, or air going into the engine and fuel going into the engine. And then we have compression, where the carburetor gets that mixture and it combines it, and it is located right here. And then we have combustion, which thanks to the spark plug, a spark is produced from the spark plug. Wow, great name. And it ignites the mixture, and all the heat produced from this little combustion pushes down on this valve, and it pushes it down. And down here we have this connecting rod. When it's pushed down, it turns it, allowing motion for the wheels. And then finally we have exhaust, where all of the unused fuel and air mixture that wasn't used gets wasted, or not wasted, but leaked. Actually, that's worse. Gets thrown out of the system through the exhaust in the back. I'm sure most of you know what exhaust looks like, so I don't want to show it to you guys. Alright guys, now we are back, and I do just want to touch on one last thing before I leave. I want to talk about the inertia of this vehicle. So the inertia is the resistance to change and motion. So the valves, as I was talking about, the cylinders are located right here. They're located right here, and I would remove this, but I can't because I need special tools. So the valves, the cylinders, they keep moving because of inertia. When they go down, they go back up again, and they just keep moving because they have no change. There's no change in motion because of the inertia. Inertia is the resistance to change in motion, thanks to based on its mass. Based on mass. Think of it. I like to think of it like this way. When I'm driving on the highway or driving anywhere else, if I take off my foot off the accelerator, it's not gonna magically stop the vehicle. No, it's not. It's gonna keep going because there's obviously gonna be some resistance to change. Since I did just touch on that, I also want to touch on acceleration. When taking in the air and fuel, make sure there is a sort of lever that is horizontal, or let's just say horizontal for for our sake. And when you push on the pedal, it actually makes the lever turn, allowing more fuel and more air mixture to go in, which then increases the amount of thermal energy inside of the valve, and thus more thermal energy means more conversion into mechanical energy, which thus means more power, meaning more acceleration on the wheels. So basically, yeah, this is my project. Thank you everybody for listening. I thank you for your time.